Let's look at this question here, which is from one of the school tutorial, which is on integration. Let's say I can do this proficiently. So the first one, we're told to show that tangent to the power of 3 is given by this expression here. So I'm going to just write it down. This case here will be d theta. Then we're just going to be tangent. Then we're just going to use chain rule, right? Chain rule, we have this outer layer, then the inner layer here. Okay, so it's not an issue. So if you're going to differentiate the outer layer, it'll be 3 tangent. This is power rule, power function. So 3 multiply down, then you minus this power by 1, so it's 2. Okay, then inside would just be secant square. Differentiate tangent is secant square. There you go. So we know that anything to do with tangent square and secant square, you need this formula here. So usually what I'll say is, because it's not given in MF27 or the MF26, right? What we do is we start off by writing this out. Cosine square A equals to 1. You just try to derive it. Okay, then you just divide everything by cosine square. The rationale is very simple. You just want this to be tangent square A plus 1 equals to secant square A. Okay, once you get that, you because now you look at the expression they want us to express. They want us to express in terms of tangent and secant square. So in other words, we need to get rid of this secant square here. We need a power of 4 of tangent, right? So I'm going to just replace secant square as tangent square. So 3 tangent square theta. Secant square is tangent square theta plus 1. Great. And from here, I'm going to distribute it. I just need a power of 4 for tangent. Okay, then I get my power of 4. So I'm secured. Then after which, same thing. You need a secant square. So this case here, I'm going to just write this down. We know that the tangent square theta is secant square theta minus 1 by using this formula here. Okay, so this formula, just try to learn how to derive it because it's not given. There you go, we got the answer. Okay, got it. Shown. Great. The next one is hence or otherwise phi tangent tangent about 4, tangent 4 theta, right, the integral. So what you need to understand is, if you differentiate this, you get this guy. Okay, so essentially you integrate this guy, you get back this, right? So you can just write this down. So integrating the answer we have, we get tangent cube theta. Okay, obviously there's a plus c if you want to write it down. Then we need this from 0 to pi over 4, but let's look at, okay, we can integrate this guy, no an issue. Integrating secant square is tangent. This we can integrate as well. So I'm going to just write everything out. This integral is what we want to find, not an issue. You can write a plus c here. I'm just write a plus c at the end here. Okay, great. So this case will be 3 tangent about 4 theta d theta. This is what we want to find. This integral is what we need to find. Then this is 3 tangent theta minus 3 theta equals to tangent cube theta plus c. Okay, bring everything over, make this a subject, because this is what you need to find. So this guy is another constant, so you don't really need to worry about this guy. It's the same thing. So now, because we need to evaluate the what do you call it, the definite integral here, so we're just gonna put in the boundary. You can ignore the constant behind, okay, because it will cancel away. So this could be ignored. So we just put pi. Understand this. Tangent 45 degrees, tangent pi over 4 is obviously 1. Tangent 0 is 0. Okay, so that's that. Then we're going to just substitute it in. Tangent 45 degrees is 1 minus 1 plus 3 pi over 4 over 3 minus of 0. Oh, there you go. This is the answer, I think. There you go. Okay, so that's the answer. That's how I do this question here proficiently.